Hi everyone, this is the Solar Electrical Online Training General Introduction, and the objectives of this particular video is to understand number one, why do we need to go for solar energy? Two, what is the solar energy potential that we have? And three, what is the recent market trends in solar industry? And number four, what are the challenges faced by using solar energy? Now, coming to the first question, why do we need to use solar energy? The first reason is the fossil fuel prices are rising, and in this particular graph, you can see that since 1970, where the cost of a barrel of crude oil was somewhere around $25, and right now, which is 2014, it is $100, and by the year 2050 it is expected that the cost of the crude oil will reach around $300, which is going to burn a huge hole in our pocket. Now, the other reason, the solar panel cost is decreasing at a rapid pace, and this is a nice plot which shows about how the cost has been reducing since 1976, where the cost was around $80 per watt peak, and as you can see, in the year 2012 it came down to somewhere around $1 per watt peak, and in 2014, that is this year, it was around $0.6 per watt peak, and it is still reducing, which is a good sign in itself. The other reason, diminishing fossil fuel reserve. So we need to be really worried about this particular point, because we thought that we can keep using these fossil fuels and not worry about its reserves, but this particular plot shows crude oil is going to exist only for 53 years, natural gas is going to exist for another 56 years, and coal for another 109 years if we keep consuming these fossil fuels at the current pace. And the other reason, global warming is happening because of human activity, and this is a plot of the concentration of carbon dioxide in the atmosphere along y-axis, and the x-axis is the time scale starting from 1000 to 2000, and the other secondary y-axis talks about the average global temperature. As you can see, since 1000 till 1900, the global average temperature was somewhere around 13.7 degrees centigrade, whereas after this 1900, due to industrial revolution, what we started doing was we started consuming a lot of fossil fuels, and we started burning a lot of coal, which in turn dumped a lot of carbon dioxide into the atmosphere, which led to something called greenhouse effect, which led to the rise in global average temperature. So the temperature started rising from 13.7 to somewhere around 14.5, which comes out to be 0.8 degrees centigrade. Now, you might be thinking, 0.8 degrees centigrade, is it a big deal? It's hardly anything. But yes, it is a big deal, and this particular picture tells us why even a small rise in temperature is going to have a huge impact. Let's start with this. So we have already reached this 0.8 degree centigrade temperature rise. Now what is happening because of this? Heat waves are happening, which means summers are going to be really hot, and the ocean temperatures are rising, Arctic ice cap is melting, and the sea level is rising. And because of this, the water starts encroaching into the shore, and a lot of land is being lost because of it. Extreme weather events, as you might have seen, on news that a lot of floods have happened in the northern India, and species extinction is happening, and this is just because of a 0.8 degree centigrade rise in temperature. Now let's move on to the left corner. So what will happen if the temperature rises by 1 degree? Again, species are going to get extinct, the coral reefs are going to get destroyed. Now island nations will get submerged underwater, and this is just for a rise of 1 degree centigrade, which is expected to happen in another 20 years. Now, what will happen if the temperature rises by 2 degrees centigrade? The entire Greenland ice cover gets melted, polar bears will get extincted, and the drinking water supply will get affected. Now, 3 degrees centigrade, we're going to have a lot of food shortage, the Amazon forest is going to collapse, and a lot of environmental refugees are going to be created, which is going to put a lot of pressure on the economy as well as the food reserves. Now, there's still more. If the temperature rises by 4 degrees centigrade, as you can see, 33% of Bangladesh is going to be underwater. And this is where things are going to get really bad, where these permafrost ice, which is permanently frozen gases, are going to get released because of the rise in temperature, and this in turn is going to increase the global average temperature, which will lead to further rise in temperature, causing the temperature to rise by say 5 degrees centigrade, 6 degrees centigrade, and 6 degrees centigrade is the point at which there's going to be mass extinction, and as we say, the world might come to an end. Now, so we have a serious problem happening right now, and what do we do about it? And just to summarize, why do we need to go for solar energy? Number one, cost of fossil fuel is increasing. Cost of solar PV panel is decreasing at a rapid pace, and we have concerns over diminishing fossil fuel reserve. And number four, climate change issues caused by pollution of the atmosphere. And last, solar resource is free of cost. Now coming to the solar PV potential, and this is a very interesting plot. As you can see on the figure, this is a map of the world, and these colors represent the average global solar radiation over a year. So what it means is that throughout a year at these particular regions, what is the average solar radiation? The red color represents somewhere around 350 watt per meter square. You need not be worried about what this watt per meter square represents. We are going to discuss in detail about these things. So all you need to know is that higher the number, better is the solar potential that we have. And as you can see, India has a very good solar resource, which is a good sign. And now coming to the figure, you can see 6 points on the figure. So these points represent the areas where if we install solar panels, and the solar panel, the solar power plant size, if it's of the size of these dots and they are installed at these places, then that is enough to meet the entire world's energy demand. I repeat, if we install solar power plants of the size of these blue dots at these 6 places, they are enough to meet the entire world's energy demand. Now, and this is a very conservative estimate because we are considering an efficiency of 8% of these panels, whereas now commercially available panels have an efficiency of more than 16%. Now we have a huge potential of solar energy which needs to be tapped and exploited. Now coming to the current scenario, so we have a huge solar potential, but what are we doing with it now? So we consume electricity, and the source of these electricity in India, let's look at the breakup. The fossil fuel is the main source of electricity in India, which constitutes to around 69%, and 16% electricity comes from large hydro, wind another 8%, small hydro is just 2%, nuclear 2%, bagasse, which is the residue after sugarcane is crushed, and solar 1%, and biomass 1%. And the most important thing that you need to observe over here is we are using just 1% of the solar resource, that we are just using 1% of the solar energy that is required to meet our electricity demands. Now, I really hope this solar and fossil fuel exchange places, and that will be a really good thing for our environment as well as our nation. Now, solar PV market trend in India. Yes, we have a huge potential. Now, what is happening in India? Since 2010, you can see that the amount of installations that have happened has been increasing gradually at a very good pace. Now, 2010, it literally, there wasn't much solar PV installations. As you can see, 2011, 2012, 13, 14, the solar PV installation capacity has been increasing gradually. Now, coming to the challenges of using solar energy. Why is solar energy not popular? And there are a few reasons for it. Number one, the initial investment is very high, and this is decreasing because of advanced technologies and better manufacturing processes. Number two, non-availability of solar resource during night time. We have this is the reason why we need to go for battery banks which store the energy during daytime, and we get to use it during night time. And the solar resource is irregular. So this is a concern, because if a solar panel is producing electricity and if there is a sudden cloud cover, the electricity generation drops drastically, which means there is going to be fluctuations in the output of the solar panel, which is not a desirable sign. So that's another challenge. And the last point, the batteries are expensive and it needs to be replaced every few years. And this is a big reason why the cost of solar energy is very high. So this is about this particular module, and let's see about what we are going to do in the subsequent weeks. Now, this is the breakup of this particular course structure. So we have 5 modules. The first module talks about the different fundamentals, like a general introduction to climate change and other things. And we have the next video, which is going to be on solar energy, and we are going to study about solar angles, and we are going to go into brief fundamentals of electrical and electronics. And the next module is about what kind of solar cells we have, what are these electrical properties, and the different PV modules. The third module is going to be on inverters, battery and charge controller. The fourth module, how do we actually do something called shading analysis? How do we design systems which are both grid connected and standalone? And the last module is going to be on policy, economics and tariff calculation, which needs to be done when a solar power plant is set up, and a brief software training. And the software that we are going to use is called System Advisory Model, and there's going to be a case study and an entrepreneurship. And the next video will be on introduction to solar energy, and I hope you enjoyed this module. Thank you.